Assalamualaikum and good morning. So today we are from group 7. We want to present experiment 3, which is major losses in pipes. My name is HAREEZ and I want to present my part, which is abstract, objective and also introduction. So for the abstract, the main aim of this experiment was to determine pipe friction factors and resistance coefficients and to show how the friction factor varies with Reynolds number by manipulating the flow rate of the fluid in the pipe. So the major principle used in this experiment was the Bernoulli's equation, taking major head losses into account and minor losses in negligible. So these major losses were normally due to the wall friction in the pipe and viscous forces between layers in the fluid. Next, objective. So first is to measure the friction losses of flowing fluid in the pipe that affected by the flow rate, pipe diameter and surface roughness. Second, to explain the factors that affecting pipe selection based on major head losses. And for the last one is to determine the factors that affecting inaccuracy of data. So for introduction, so basically in this experiment, the pressure loss or the head loss for a flow subject to friction will be determined experimentally. So the flow is considered steady at Reynolds number, where Reynolds number is bigger than 4,000 and smaller than 500,000. So with turbulent pipe flow, the pressure loss is proportional to the length of the pipe, coefficient of the pipe friction, density of the flowing medium, and the square of the fluid speed and the flow speed.
Assalamualaikum. My name is SYAFIQ and I will be presenting the theory and the methodology. To calculate major head loss and pressure loss in the turbulent pipe flow, we use this equation. Equation 1 and equation 2. Next, this showing the table 1, which is equivalent roughness for the pipe. Next is the Moody chart, which show the relationship between Reynolds number F and diameter. This is the formula to find the Reynolds number. The table 2, which is showing us kinematic viscosity of water as a function of temperature. The speed of flowing medium can be calculated using the data of the internal pipe cross-sectional area. This is the formula for the Blasius formula to find F, and this is the formula to find F for the Colebrook formula. The F in turbulence for flow also could be determined using a Moody formula. Methodology. This is the apparatus used in this experiment. First, both the feeding and return hose were connected to the tested pipe section. Second, the manometer tube was connected at one of the two tube manometers to the tested pipe section. 3. The main switch and the pump were turned on. 4. The gate valve was opened slowly until the reading of rotameter or actual flow rate reached. 5. The ventilation valve lid was opened on top of the two tube manometer to let the water overflow from the system. 6. The gate valve was closed and the pump was turned off. 7. The ventilation valve was slowly opened on top of the two tube manometer until the preset minimum reading of two tube manometer. 8. The gate valve was slowly opened until the level of water at 2 tube manometer of H1 reached the maximum while H2 at minimum. First reading was taken. 9. The QX was reduced to 5 different values by adjusting the opening of gate valve. 10. The manometer tube at the 2 tubes manometer was transferred to the differential pressure sensor. 11. The flow meter value was adjusted as previous reading. 12. The reading of differential pressure sensor was recorded. 13. The QA was reduced to 5 different values by adjusting the opening of the gate valve, same as per data before. 14. After finish all the reading, the gate valve was closed and the pump was turned off. 15. The feeding and return hose were changed to another pipe section. 16. The same procedure was repeated for the other pipes. And lastly, after finish, all the manometer tubes were removed from the system. The gate valve was closed, the pump and the main switch were turned off.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ASHRAF bin Malazli. So today I will present for my part, which is result discussion and conclusion. So for result, we have 5 result, which is 5 different test pipe. So the first one is a galvanized pipe. Pipe galvanized, which is the temperature is 30 Celsius, internal diameter 12.7 mm, length of pipe is 1000 mm. So we have to find the value of delta H, which is we have to H2 minus H1. So as you can see in the slide, it shows that the data for delta H for galvanized pipe. Next, for pipe copper at 10 mm, copper pipe at 10 mm times 1 mm, temperature is 32 Celsius, outer diameter at 10 mm, thickness 1 mm, length of pipe 1000 mm. So it shows that the data for delta H of copper pipe. Next, for PVC pipe at 60 mm times 18 mm, the temperature is equal to 34.5 Celsius, outer diameter 20 mm, the thickness is 1.5 mm, and the length of pipe is 1000 mm. So it shows that the data for delta H, the value of delta H of PVC pipe 60 mm times 18 mm. Next, for PVC pipe 20 mm times 1.5 mm, the temperature is 33 Celsius, the outer diameter is 16 mm, the thickness is at 1.8 mm, and the length of the pipe is 1000 mm. It shows that the value of delta H of PVC pipe 20 mm times 1.5 mm. Next, the last test pipe, which is PVC pipe 32 mm times 1.9 mm. Temperature is 35 Celsius, the outer diameter is 32 mm, the thickness is 1.9 mm, and the length of pipe is 1000 mm. It shows that the value of delta H for PVC pipe 32 mm times 1.9 mm. So for discussion, we have to find the coefficient of friction F for each of the test pipe, which is we have 5 test pipe in our experiment, and calculate by using formula of Versus, Colebrook, and Moody. So for the first test pipe, which is pipe galvanized, we will get from Moody chart the coefficient of friction is 0.042. When we use Versus formula, we'll get F is equal to 0.029. Colebrook formula, we get 0.0439, and for Moody formula, we will get 0.005807. So next, for pipe copper at 10 mm times 1 mm, when we use Versus formula, we get 0.0249. When we use Colebrook formula, we get 0.0246, and when we use Moody formula, we get 0.0047. So for Moody chart, we get F is equal to 0.026. Next, for PVC pipe 60 mm times 18 mm, when we use Versus formula, we get F is equal to 0.0297. Colebrook formula, F is equal to 0.0292. Moody formula 0.0053. So for Moody chart, the coefficient of friction F is equal to 0.029. Next, for PVC pipe 20 mm times 1.5 mm, when we use Versus formula, we get F is equal to 0.0227. Colebrook formula, we get 0.0226. Moody formula, we get 0.0042. So from Moody chart, the coefficient of friction F is equal to 0.024. Next, for PVC pipe 32 mm times 1.9 mm, when we use Versus formula, we get F is equal to 0.024. When we use Colebrook formula, we get 0.0237. For Moody formula, we get 0.0045. So for Moody chart, the coefficient of friction F equal to 0.023. Next, for we have to find the major head loss, which is HL value that we obtain for our experiment to rank the pipe in ascending trend. So for the galvanized pipe, the value of HL equal to 0.01294 meter. For copper pipe, at 10 mm times 1 mm, we get HL equal to 0.123 meter. For PVC pipe, 60 mm times 18 mm, HL is equal to 0.0264 meter. For PVC pipe 20 mm times 1.5 mm, HL is equal to 0.5228 meter. And the last one, PVC pipe 32 mm times 1.9 mm, HL is equal to 0.0237 meter. So as you can see at the lower part of our slide, it shows the ranking of the pipe in ascending order based on their major head loss. The first one is PVC pipe, and the last one is PVC pipe 32 mm times 1.9 mm. Next, PVC pipe 18 mm times 18 mm. Third, copper pipe, fourth, galvanized, and the last one is PVC pipe 20 mm times 1.5 mm. So when we do our experiment, we have to make sure the factor that contributing to error or inaccuracy in our experiment data, so that we can improve that data that we get or the result that we obtain. So the error that may occur, which is parallax error during the flow measurement. Second, the common mistake that when we read the Moody charts, so we have to make sure that we use ruler and pencil that when we read the Moody chart, so that we can see clearly the lines and the point. The third is calculation error from in measurement. For precaution, we have to be aware of the logarithmic nature of the axis and labels value, which is in Moody chart. Next, make sure the eye of the reader parallel to the meniscus, which is we have to make sure that our eye is parallel to the meniscus when we read the value of H. The last one is reading should be taken twice or more, so that we can make sure that the value that we read is correct and accurate. So for conclusion, from this experiment, we learned that any pipe will have a major losses due to internal friction of the pipe. When the diameter pipe is larger, and it make the velocity become slower, so that it also cause the percentage error become larger. So the experiment give us a clear understanding of the pipe for major loss. So I think that's all for me. Thank you.